Chapter 9, Distance from a Point. Determine the coordinates of the point on the line xyz equals to 1 minus 1 2 plus s 1 3 minus 1 that produces the shortest distance between the line and a point with coordinates 2 1 3. Okay, let's first try to understand this question, right? Let's think that this is our line, right? This is a line xyz with this direction 1 3 minus 1, and let's assume that we have a point 2 1 3 somewhere here. Okay, then of course the shortest distance between the point and the line will be this, right? The idea is to find this point. Now how to find it? So the method which we are going to adopt is something like this. Let's take any general point on the line. Let's say this is a general point, correct? So the general point coordinates we can get from the parametric equation, right? And then we can find the direction cosine of this. Now, which is a general point with x value there, correct? And we know the direction cosine of the line. So the direction vector of the line, right? So what we will do here is we'll find the direction vector between the general point and the given point 2 1 3. Now, the two direction vectors, if they are perpendicular, then their dot product should be 0, right? That's how we are going to get the x value, which will correspond to this point, right? And once we get that value, then we know the point on the line which will be shortest to the given point, right? So that's how we are going to do it. So since the line is xyz equals to 1 minus 1 2 plus 3 times 1 3 minus 1, the general point on this line will be x equals to 1 plus s, y equals to minus 1 plus 3s, and z equals to 2 minus s, correct? Now the point given to us is 2 1 3, right? This is 2 1 3. Let's call this point as P, and let's call this general point as Q, okay, for the time being. Now, so what is PQ? So we'll find basically PQ dot this direction cosine, which is 1 3 minus 1, and we'll equate that to 0 to find the value of our parameter s, correct? So PQ should be this minus 2, right? So we'll say PQ will be the x value, let's write it like this, 1 plus s minus 2. This is my s value, right? The y value will be minus 1 plus 3s minus 1, and the z value will be 2 minus s minus 3, right? Dot product of the direction vector of the line, which is 1 3 minus 1, right? And this should be 0 to get us this point q dash, the one which we want to get, correct? So let's do our dot product. So this times this, that means 1 times this, all this. So 1 minus 2 is minus 1, so I'll write s minus 1. And here if I do 3 times minus 1 is minus 2. So 3 times minus 2 is minus 6. And 3 times 3 is 9. So plus 9s, right? And here we get 2 minus 3 is minus 1. Minus 1 times minus 1 is plus 1. As far as s is concerned, minus s times minus 1 will also give us plus s, which is equal to 0. Perfect. Now if we combine our s, we'll get 7 s1 plus 9 plus 1 gives us 11s. And the value of y is minus 1, minus 6 and plus 1, so we get minus 6 here equals to 0, and that gives us s is equals to 6 over 11, correct? So that is the point s for us, correct? If s is 6 over 11, then we can always put in this value of s in our equation, right? and then find what x, y, z are. 6 over 11 we'll put here, so we'll say it is 1 plus 6 over 11. That is the value of x. Y is minus 1 plus 3 times 6 will be 18 over 11, right? And the z value will be 2 minus 6 over 11, right? So these are the values which we get for x, y, and z, correct? So this could be simplified. I mean, fractions could be solved. 11 times 1 is 11. 11 plus 6 is 17 over 11. And here minus 11 from 18 will give us 7 over 11. And here 11 minus 6, 11, this is 22, sorry. 2 times 11 is 22. 22 minus 6 will give us 16 over 11. So these are the coordinates of our point Q, right? So now we know the coordinates of Q. We have the coordinates of P. So the distance between P and Q will be this minus this, and we can use the distance formula, right? So we'll do it here now to find the distance PQ, right? So distance PQ, that means the absolute distance PQ will be equals to square root of x1 minus x2. So we can use 2 minus this, right? 2 minus 17 over 11 square plus 1 minus 7 over 11 square plus 3 minus 16 over 11 whole square, square root, right? So you can solve this to get your answer, right? Use calculator and then solve it, right? So let me see what best I can do about it. So it is 22 minus 7. 22 minus 7 is 5, right? So it's 5 square. Here it is 11 minus 7, so it is 4 square. And here it is 33 minus 16, right? So 33 minus 16 is 17. So plus 17 square, right? So you can add this and then figure out, and the denominator is 11, right? So let me take, okay, let me write like this, over 1 over 11 square. That's not bad, that's not bad, right? So you can figure out what is the answer for this. It will be 1 over 11 times square root of all this. Is that okay? So I don't have a calculator at present, so you can calculate this value. 5 square, 25, plus 16, plus 17 square, and whatever you get, right? So you can calculate this and then write down your answer. So the idea here is that you have a line and you have a point outside the line. So what you do is take a general point on the line, find the direction vector between the point and the general point, right? And then do a dot product between PQ and the direction vector of the line and equate it to 0. Equating it to 0 means this line is, we are trying to find the value of x, y, z, that means the value of our parameter, which could ensure that the line PQ becomes perpendicular. Once it becomes perpendicular, then we have the line point on the line, which should give us the shortest distance, right? So that is how we'll calculate the shortest distance, okay? I hope you understand the whole process. Thanks for that. And if there is any problem, write down your comments and then we can look into it. Thank you.